Okay, okay, okay. I will wait. I will wait.
Okay, thank you.
এই টাকাটা মাসওয়ালাদের টাকা, এই টাকাটা একটু স্প্লিট তো করে নাও।
Now, beta, I would like to start your class. Okay. So, last class little bit I have explained about your this 8085 processor. Now today I want to explain the programming part. Before that, little bit I would like to recap. So here, just you remember only the that is a your 16-bit address bus, and you try to remember 16-bit address bus you have and 8-bit data bus. And another thing, if you have processor and memory, address bus is always unidirectional and data bus is bidirectional. And why it has happened? Because if you want to write something or processor wants to write something, the data will transfer from processor to memory, and processor wants to load something, on that way data transfer from memory to a processor. So through the data bus, data will move. So you can see that both the direction data can move. So that's why it is a bidirectional, and address is always going from processor to memory. Whatever it is some data processor wants to write on memory or processor wants to read some data from memory address. So address is unidirectional. Okay. Now next is that little bit the uh, internal architecture. Here is very important, that is the register B, register C, register D, register E, H, L, and the accumulator. So these are you can use for operands and in instruction you can use these registers. That's why these are called the programmable registers. And for memory address we use the stack pointer and program counter. Now next is that uh, little bit I want to say the different type of the instructions. So data transfer instruction, data can move from one place to another place. Arithmetic operations means that addition, subtraction, and logical operation means that logical and or operation. Branch instruction means that you can use a different type of jump instruction, and control is also like that. You can use some compare instruction. Okay, so branch and control you can use with the help of jump, and these are the types of your instructions are available for your 8085. So I'd like to summary, and these are the instruction: move immediate, load instruction, store instruction. It is another type of load instruction, another type of store instruction. So last class I have told you, if you have the processor and if you have memory, so processor wants to store some data into memory, so this operation is called the store operation. And when processor would like to process some data, on that when it wants to load, so load means that load operation will be when memory data will move from memory to processor. This operation is called the load operation. And these are also our different types. I will explain when I will explain the your programming part. And you know that for CPU, one of the vital component is ALU. ALU means that arithmetic, and L for logic. Arithmetic logical operations you can do with the help of LU. So this is the addition operation. These are the subtraction operation, increment and decrement operation. Okay, and these are all are 8-bit operation. And suppose if you want to do some 16-bit operation for addition, only one instruction is available, that is the DAD. Okay. Now, next is logical operation. All are the previous, or the arithmetic operation, addition, subtraction, increment, decrement, all are the arithmetic operation. These are the logical operation. Okay, so here suppose if I write the instruction and A, B. Okay, so suppose if A represent the accumulator. Now you have some data, suppose 0 1 0 0 1 0 0 0 data, and content of register is suppose that 1 1 0 0 0 0 1 0, suppose. So it will be it should be bitwise operation. Now result always stored into the accumulator. You know that most of the operations result is always stored into the accumulator. So bitwise operation, if we do the AND operation, if we apply the logical AND operation, so it will be 0 0 1, it will be 0, here it will be 0 0, here will be 0, it will be 0, both are 1, so it will be 1 1 0, that will be 0. So you can understand that bitwise operation. Remember that it is a bitwise operation. Data is here the 4 8 8, and here I have considered 8 plus 4 12. 12 is that 10 11 12. So A B C, so C 0 8. Okay, so if you consider these two, you will have the result, that is 408 into the accumulator. Clear? So in that way, you can use the OR operation, you can use the XOR operation. It is a AND operation will be happen, accumulator and your register B, and immediate you can give the immediate data, suppose 048, it is the immediate data, and it will be AND operation with A, logical AND operation will be A, and result will be stored into A. So same as OR A, OR I, it should be OR I. Sorry, it should be OR I, and XRA and XRI. XOR operation, exclusive OR operation. Okay. Now, next is that I'm not telling the compare, branch, later I will explain. Stack operation is very important, but it takes huge at least 2 or 3 classes. That's why I omit that part. Only simple basic programming I would like to explain. Now here, two 8-bit operation, two 8-bit numbers if we want to add. So here I have considered the register A and register B. That is one data is 088 and one data is the 10. Already I have written here. Okay, and I want to add means that on that moment we have to use the instruction add. For add operation, implicitly one of the operand is A, other operand you can give here. So that operand I have given here B. So if you write the add B, meaning is that it will do the operation A and B, and after that result will be stored into accumulator. Clear? After having this data, that means addition operation, what will be the after adding what you will have? A 8 and 1, so 188. So here accumulator content will be 188, and then that data you want to store into a memory. So that memory address you can write, that is a 60008. This is the memory address. Obviously it should be the 16-bit. So 6008, the content of accumulator will be stored into the location. That location is that 60008. So STM is the store content of accumulator to the memory location. That location is 60008. So after execution this instruction, content of accumulator will be stored here. So here will be 188. Clear? Now suppose so with the help of that these operations you cannot do the 16-bit additions. Now suppose instead of 8-bit, if you consider the 16-bit, here LXI is a load operation. Already I have told you, if you have the processor and memory. So when from memory to processor, data will transfer. That is called the load operation. So with the help of memory, you can store the data, that is 12088, and this with the help of this instruction LXI, load immediate into the register DE. Okay, D represent here DE because X represent the register pair. Whenever you have any X in your instruction, you understand that that is a register pair, indicates the register pair LXI. Okay, suppose that DCX, this X represent that 16-bit operation. So for that it is used the register pair. Because of that, one register can store 8-bit, so register pair if we use on that one, it will be the 16-bit, and D represent the DE here. Okay, so DE content will be there 08. Load the value immediate data, that is a data, this is not the address. Okay, this is a data actually. So 1208, this is a data will be stored into the register DE, and with same way we can write for the LXI H. H means that register H, register L, and data is that 2310. So 2310. So higher byte will be stored into the H, and lower byte will be stored into the L. Okay, you try to remember this. Now, so now after having this data,
Ma'am, could you explain the DAD part? Ma'am, I didn't get the DAD part.
I'm coming to that. So I have explained these two parts. Okay. Now I am coming with the help of these two. We can load into the register DE and HL with the value of 12088 and 2310H. Both are the 16-bit. Okay. Now this is a DAD instruction. DAD instruction is that same as add, but for add we use the one of the operand is accumulator, but for DAD instruction one of the operand is that HL. So content of HL and content of D will be added, and after addition the result will be stored into the HL. So HL will be act as a accumulator. Clear? So content, that's why I have considered here the H register and another register D. Here you can write the B also. Okay, BC on that moment. You can write the H also, HL plus HL. Okay, so after that you can write register pair. So first name you have to give. If you want to BC, so write the B. If you want to D, so D. If you want to mention the HL, so only write the H. H represent the HL, D represent the D, B represent the BC. So here I have considered the register DE. So for that reason, I have considered here the DAD D. So DAD D means that content of HL, content of DE will be added, and after that addition result will be stored into the HL. Now this value you can store into the memory. How you can store? Another instruction I have considered. This is a very interesting instruction, SHLD 6008. What is the meaning? Can I write here?
What if there is a carry?
Yeah, carry you can handle in different way. That is very, sorry, beta. Thoda wait karo. So later I'll explain the carry. Carry is very interesting in the different way you can write. But suppose that here I have considered there is no carry after addition. Okay. So
Okay.
what I can do, SHLD. First I want to explain the SHLD. Then I will like to handle. I will explain the how to handle the carry. Okay. So now SHLD. So meaning is that store content of HL register into a memory location. Location I have used the 6008. Now you know that one memory location can store the 8-bit. Okay, so suppose this is a 6008, and here you can understand that what is the result, 18 here 325, and it will be the 2 plus 1 3. So your result is that 35188. So here it will be stored the 188. That means HL will be here 35, 18, first L content will be stored into this location 6008, then increment the address, that will be 60028, and content of 8 will be stored into the next location, that is 0018. This is a 60. This is a 6000. So next address will be 6001. 6001. So lower location will store the lower byte. Higher location will store the higher byte. What is the higher byte? It is the higher byte. This is the lower byte. So lower byte content, byte content will store into the lower location. Lower location means the 6008. After that, the memory address will be incremented by 1, 60018, and 35 will be stored into the 6001H. Why? Because one location can store the 8-bit data, but HL contain the 16-bit data. For that, this SHLD can store the content of HL with the help of address 60006001. But in the instruction, it is not required to mention. Only you mention the first location. Automatically, the processor will increment and will store the higher byte into the higher location. Clear? Now another thing, one student asked me that how to handle your carry bit. So suppose that if it will generate any carry bit, now suppose if you consider 55120, suppose here you consider the C, suppose C whatever it is. So C plus 5 means that C D E F, then C means that, what is that beta? A, B, C. That means 10, 11, 12. So 12. 12 plus 5, that is a 17. Okay. So obviously here it will be generate some carry. Okay. After having this value. So on that moment, what you can do, carry flag will be 1 if you have the carry. Okay. So for that, what you can do, use the another instruction that is called the ACI 00H. Before that, you have to clear the accumulator. Accumulator content should be 00. And for that the instruction, what you can do, content of accumulator, content of carry bit, and content of immediate data. I for immediate data. Now accumulator content is 00, it is 00. Automatically that carry, after operation, this data will be stored into the, result will be stored into the accumulator. So accumulator content will be the carry value. So you have to write a fresh instruction, that is, first you clear the accumulator with the help of move A, 00. You cannot use the XRAA to clear the accumulator. Because of that, XRAA, if you use on that mode, carry will be modified. Carry can be modified. But if you use any data transfer instruction, on that moment, carry cannot be changed. Any data transfer instruction cannot modify the flags. Cannot modify the flags. You remember that this is the specialty of the data transfer instruction, where you will use the logical and arithmetic operation, and where you use the data transfer instruction. It is very, very important. You keep it in mind. If you want to use the carry flag, so obviously don't use the arithmetic and logical operation. Instead of that, you have to use the data transfer instruction. So after doing this, what you can do, this thing you have to do, first move A, 008, then you write the ACI 008. So what is the meaning of this? That is the accumulator content, carry flag, and your immediate data. Immediate data I have considered the 00. So this will be stored into the accumulator. So this is 00, this is 00. So obviously carry value will be stored into the accumulator. So after that, after doing this two operation, again you can use the another address. Suppose STA, already you know that 600H stored the lower byte, 6001 is used for your higher byte. So next location will be the 60038. So you can store the carry value into the memory location, that is 60038. So your data will be more than 16-bit. So these locations you can use for your storing the result. So complete result you can have in this one, so 2, sorry, not the 3. This is 2. This is 2H. Clear? So 0, 0 for lower byte, this is for the higher byte, and this is for the carry. So all the data you can, all the bits of your result you can store with the help of this. So carry you can handle easily. It doesn't create any problem. Okay, and suppose if it is a 32-bit, so on that moment also, next example will help you how to handle this 16-bit or 32-bit or 64-bit. Easily you can do this. Some instructions are available. Next example I'm going, and then you can understand. This is a 16-bit. I use the 8-bit operation without using the DAD instruction. How you can handle? Now, if you have the 8-bit, suppose in this way, I have considered the BC and DE. So BC and DE register I have used here. So if you use the 8-bit, so first you have to add this thing. After that, if you have any carry, with this carry and B and D, if you add, ultimately you will have the result. Clear? You have the 16-bit operation. So for that reason, BC, that B means that that is 10, and C means that 08. Okay. So it is a content of B. This is a content of C. This is a content of D. This is a content of E. Now first we have to add a 08 and 10. You know that simple addition operation. So we know the instruction, add instruction. So one of the operand is accumulator. For that reason, one of the value maybe C or maybe E, what any value you can store into the accumulator first, then you add with the other value. So that is a plus E. That means it is a C plus A, and it is stored into the A. Now after this addition, I want to store the result into suppose HL register. So for that reason, content of accumulator, I am trying to move to the register L. Same way I can use for the this two data. This two data means the B and D. So I have moved the data of B to the accumulator, and then again add. But here add, I have used another instruction, that is the ADC. Here I have, sorry, here mistake I have done. That is the carry actually. Okay, add means that add and plus any register, and add C means that add accumulator, register content, and also C. So there is a possibility to have a carry. Okay, here you may have some carry. For that reason, you have to use the instruction add C. So obviously you can have these three, you can add, and that value obviously first it will store into the accumulator. From that I have moved to the register H. So ultimately you can have the result into H and L. And suppose again if you want to handle the carry on the same way, again you have to use the move A comma move MBI A comma 00H, SCI 00H. So then you can use the any location, or you can keep on that carry. Okay, so in that way you can do the 16-bit operation. Now suppose if you want to do the 32-bit operation, so this process will be repeated again. Okay, so in that way you can handle for the 32-bit, 64-bit, whatever the number of bits you can handle. So keep it, remember, your register is very limited, so very efficiently you have to handle the your registers. Okay, so
Ma'am, I have a question.
tell me.
Ma'am, in the 16-bit, why are we using load immediate instead of move immediate like we did in the 8-bit?
I can't understand your question again. Tell me better.
Ma'am, in the 8-bit, ma'am, adding to 8-bit numbers, we are going for MVI A08H, right? As the first command.
MVI, where I have written better MVI?
Ma'am, two 8-bit numbers, 8-bit numbers. Ma'am, example, ma'am, adding
Oh,
to 8-bit.
good. Last question.
Yes, ma'am, last question, ma'am.
This part.
Ma'am, it's still, yes, ma'am, yes, ma'am. We used MVI, right?
Yeah.
So why are we using a different syntax for the 16-bit portion, ma'am? I didn't get that.
What I have taken, check it.
Ma'am, we used LXI,
Yeah.
ma'am.
Yes. LXI, because of that, LXI is another instruction. Load the immediate data to the register pair. Here I have considered 16-bit. This operation you can do with the help of the two MVI instruction. One is that MVI, that is a B and C. So some B you can store the 10. Again you can write MVI C comma 08. In that way also you can do. Okay. But instead of using the two instruction, I have used the one instruction, load instruction. Load means that immediate data will be loaded into register pair BC, because I want to consider the 16-bit data. That's why. So with the help of programming, you can use the different methodology. You can use the MVI, or you can use the LXI. LXI I can use, already I have told, X represent the register pair. Whenever you use the register pair, that means you can handle the 16-bit data. For that reason, I have used the LXI. Clear? Beta?
Okay, ma'am. Okay, ma'am.
Okay. And another instruction here, I have used the SHLD. SHLD means that stored content of HL to the memory location 60008. You have the HL register. So the first content of L will be stored into the 6008, and again increment the address 60018, and content of H will be stored here. So always you remember lower byte for lower location, higher byte for the higher location. This is the syntax of your 8085 programming. Okay, and RST7, that is depends on the assembler who designed the system. Based on that, he can handle this interrupt signal to aid your program. Clear? Now a little bit I will explain that. Series calculation kahan hai? Okay, I have removed most probably. No, here. See that this is a series calculation. How to handle the series? Same way, whatever you use the syntax for your C programming, you can use that. So for your series addition, always you use the sum equals to 0, isn't it? Whenever you use the instruction, suppose sum equals to sum plus I. So limited number of instruction is there. I would like to 10 natural number I want to add. So here I use the C register C as a counter. Okay. Now C as a counter. So 10 numbers. 0A means that 10 basically in decimal. Sorry. This is a 10. And here XRA accumulator I use as a sum. Okay, so you try to assume that which register is for which purpose you want to use. That you have to first select. So C I use here for counter, and for the sum I use the here accumulator. Okay, now here I add the C. Okay, A plus C, and counter I have used the down counter. C is the C minus 1. In this way, it will check that Z flag is 0 or not. So this decrement C, that will be decrement, but when this content of C is 0, on that moment Z flag, you know that 5 flag is there. One of the flag is the Z flag. Z flag will be 1 on that moment. This is a 0. Okay, not 0. On that moment, it will go to the up. So this process will be continued until and unless she will be 0. After, when she will be 0, it will exit from this, and then it will store the addition value. Addition value you have the into the A. That value you can store into the memory location, that is 60008. So here C is a counter. A is first I have assigned with the help of 10. A is assigned for the 0. Here I want to A equals to A plus, that is a C counter, basically down counter I use. So for first term this will be the 0 plus 0A. So it will be the 0A. In that way, again go to the here 0A plus 0, 9 plus, in that way it will add, and when it will be the 0, on that way it will be come to here, exit the loop. So automatically you can have all the value up to 1 you will have. So down counter I have used. The counter C is the decrement, at the time it will be added. So after that you can have, and after having all the value, you can go to the you can exit from the loop, and ultimately in accumulator you have the result. That result, with the help of this instruction STA, stored content of accumulator into the memory location, that is 60008. You can store there.
Ma'am,
Clear?
what is the value of Z, ma'am? Like, or initial value of Z, ma'am?
Z I have done here, that is a XRAA. Huh? So
Okay.
see that this XRA is a you can say that this is a logical operation. Okay, remember that logical and arithmetic operation, all flags will be modified depends on the result. Okay, so
Okay.
XRAA, whatever the content of A, if you do the exclusive OR operation, always it will be 0. Clear? So on that moment, your Z flag will be, all will be 0.
Okay, ma'am. Got it, ma'am.
Okay,
Got it.
so automatically you can clear carry flag, you can clear your accumulator content. Sum equals to 0, because if you want to create the loop, this initial value, it will be 0. You have done in your C programming. Okay, same way you can do for accumulator and for the carry flag. Okay, so in that way, if you create the loop easily, you can sum this type of the series. Okay, now another example I would like to say, that is a multiplication. It is a, see that you don't have any multiplication operation in your 8085. So on that moment you have to do the repeated operation, repeated addition operation. Here I have considered the 05 plus 04. That means 5 times you will add the 4. So automatically you can have the 20. Clear the logic? So 5 times you have add the 4, or 4 times you add the 5. Automatically you can have. So again we have the C and B, decrement the C, add C times this B value. Sure, obviously we have the result, that will be the 20. And that 20 you can store into the memory location 60008. Is it clear better? Okay, now I don't want to,
Ma'am,
I
ma'am,
don't
just
have bolo.
question, ma'am. Ma'am, in the previous question, we had 0AH, like we are assuming it's 10, or is it given? Like, is there a certain number system that allows us to know that the value of 0AH is 10, 05H is 5, sir? Ma'am, like that.
This is a hexadecimal number we use in our microprocessor 085 micro. Most of the in your computer system we
Okay.
use the hexadecimal number.
Okay. Okay.
So obviously aim is the 10 always.
Okay. Got it.
Okay. Now you know that these are the addressing modes. Already I have explained last class that immediate addressing means that immediate data you can give. Okay. MVI, immediate. LXI, I means that immediate. Registered addressing mode means that you have the operands are registers. Okay. The move A comma B, all are the registered. Registered addressing mode. Direct addressing modes, you can give the direct address in the instruction. Okay. Location you can give the direct. So direct addressing. It is also called the indirect addressing mode or registered indirect addressing mode. LDXB means that content of accumulator will be stored into the location. Suppose this location is 2008. So actually BC, that register contain the 2008. So for this instruction, whatever the content of B, that will be pointed as a memory, and content of accumulator will be stored into that location. So that's why it is called the indirect addressing mode. And implicit means that no need to give the operand. So that instruction gives the information about the operand. So CMA is that complement of accumulator. Whatever the accumulator content, it does the once complement. STC is that is a set the carry flag. Whatever the value of carry, after this operation, carry flag will be 1. Yeah. So these are the addressing mode. Addressing mode is nothing but how the instruction address the operands. Based on that, we can classify
Ma'am,
the
can you
different
please
type of
explain the
addressing
set the
modes.
carry flag?
Set the STC means that set the carry flag means set means 1. So carry flag will be 1 on after this operation. After execution of this operation, carry flag will be 1. Set the carry flag. If you want to set the carry flag, STC. Clear?
Yes.
बेटा इधर ही मैं खत्म करना चाहती हूँ because I have finished little bit. If you have any question, again I will take your class after Vivasar class. I will start again. but it is a very huge theory. It is a one semester course it is, so it is very difficult to complete within 1 and 2 classes. Little bit I have given flavor of your 8085. Clear, beta?
Yes, ma'am.
Okay, so
Ma'am,
Ma'am, can you please send us the
ma'am,
slides?
you send us the slides, ma'am. Actually, it's easier that way, ma'am, because there are a lot of commands, ma'am. It's not possible
okay,
to
okay,
note.
okay, give some time. I would like to modify, then I will send you.
Okay,
Okay.
sure, sure, ma'am, sure, ma'am.
Oh, okay.